Welcome all. In this lecture, we will discuss about transfer function of a system. So consider the differential equation of a system as a3 dq by dt cube of y of t plus a2 d square by dt square of y of t plus a1 d by dt of y of t plus a0 y of t equal to b2 d square by dt square of x of t plus b1 d by dt of x of t plus b0 x of t, the general differential equation where x of t is the input signal and y of t is the output signal. So for finding the transfer function, we can take Laplace on both sides with zero initial conditions, means without any initial conditions. So without any initial conditions, we can have the Laplace of differentiation as s raised to n y of s. We are neglecting the initial conditions because in order to find the transfer function, we have to take the Laplace without initial conditions. So L of d by dt of y of t will be equal to s into y of s. Then for second order differential equation, and from third order differentiation as this one. So we can directly apply the Laplace transform here. Then this term become s cube y of s. For d square by dt square become s square y of s. d by dt it become s into y of s, and y of t become y of s. And here also s square x of s will be the Laplace of d square by dt square, and s into x of s will be the Laplace of d by dt of x of t, and x of s is the Laplace of x of t. So we can take the y of s here common and x of s here common, so it become like this. Y of s is taken from here and x of s is taken from here common. Then the transfer function is defined as the ratio of y of s to x of s, means ratio of Laplace transform of the output to the Laplace transform of the input. Y of s is the Laplace transform of output signal and x of s is the Laplace transform of input signal. So the transfer function is the ratio of the Laplace of output signal to the Laplace of input signal. So it can be defined as, from this it will be b2s square plus b1s plus b0 divided by a cube s cube plus a2 s square plus a1s plus a0. So this is the transfer function y of s by x of s. So transfer function is defined as, it is the ratio of Laplace transform of output to the Laplace transform of input when all initial conditions are assumed to be 0. Tf equal to y of s by x of s. But we have the if h of t is the impulse response of system, then any input x of t, for any input x of t, the response y of t, the output will be y of t is equal to x of t convolution h of t. So we can take the Laplace transform. So for like Fourier transform, we can say that y of s is equal to this convolution become the product x of s into h of s, where x of s is the Laplace of x of t and h of s is the Laplace of impulse response h of t. So from this we will get y of s by x of s is equal to h of s. But here y of s by x of s is the transfer function, means the transfer function is the Laplace of h of t, the impulse response. Is the conclusion here. We can, if we have the impulse response, we can h of t, we can find the transfer function directly by taking the Laplace of this h of t. It's h of s. Since h of s is the ratio of y of s by x of s, it is the transfer function. Then we can have how we can find the response of a system from transfer function. So now we know that transfer function is y of s by x of s, and again it is the Laplace of impulse response also, h of s. Again we have, for if h of t is the impulse response and for any input x of t, the response y of t will be y of t is equal to x of t convolution h of t. Taking Laplace, we will get y of s equal to x of s into h of s, or we can write y of s equal to x of s into transfer function. This is the transfer function because h of s and transfer function are same. So we can find the response y of t for any input x of t as y of t. So from this we will get y of s. So taking Laplace inverse, we can find the response. See, cell inverse of y of s which is L inverse of x of s into transfer function. So if we know the transfer function for any input, we can find the response by taking first by multiplying this Laplace x of s into transfer function, then finding the inverse. Now we can discuss the transfer function of an electrical system. So for that, take this example. So here this is the electric circuit. So we had to find the transfer function y of s by v of s. So it is known that y of t is taken as the output, and v of t is taken as the input. So the transfer function is y of s by v of s. So in order to find that, we can find this by applying analyzing the circuit and taking the Laplace. So if I of t is the current flowing through this loop, we can write the y of t will be the voltage across this resistor R. So it become R into current. So R into I of t. So taking Laplace, y of s equal to R into I of s, where I of s is the Laplace of I of t. Again, now we can let this equation is 1. Again we can apply the KVL in this loop. So it become this v of t, voltage across this is R into I of t. Voltage across this capacitor is 1 by C integral I of t dt, and voltage across this inductor is L into d by dt of I of t. Then we can take the Laplace transform without initial conditions. Means for finding transfer function, we have to take the Laplace without initial conditions. We don't want to take the initial condition. So v of t become v of s, and R into I of t, Laplace of I of t is I of s, 1 by C, Laplace of integral I of t is 1 by s into I of s, where I of s is the Laplace of I of t. Then L into Laplace of differential is s into I of s. So let's pick the equation 2. So then we can find the transfer function by solving these two equations. So from first equation we can take I of s. We have to eliminate I of s, and we have to take y of s by v of s. So we can find I of s from equation 1 as y of s equal to r, and we can substitute this in 2. So it become v of s into this I of s become y of s by r, 1 by c into 1 by s. Again I of s is y of s by r, plus ls into I of s become y of s by r. Then we can take y of s common here. Then the y of s ratio y of s by v of s, transfer function, become 1 by 1 plus 1 by r cs plus ls. So we can simplify this by multiplying RC's both denominator and denominator. So it become like this, and finally rearranging we will get y of s by v of s, that transfer function as RCS by RLC s square plus RCS plus 1. So with this we can wind up the session. Thank you.